Okay, pre-calculus class, we're going to look at vectors, sum, differences, pieces like that. Here's what I want you to do. I want you to draw somewhere just on a homework sheet of paper, just so you could kind of collect this as reference. Your first problems for your assignment today is going to be based off of this. And I just want to go over again what we saw yesterday with the sum and difference of vectors. And so I'm going to draw two vectors here, and you're going to want to draw these as well. The first one has an initial point at 0, 0, and a terminal point at negative 1, 1. We'll call that vector u. And then vector v will have, again, initial point at 0, 0, and terminal point at 1, 2. We'll call that vector v. Okay? So get that sketch, and we can refer back to that at later times as well. Yeah, so this is gonna be, this isn't on the homework from yesterday. This is gonna be, for the homework for today. I covered it briefly yesterday in our notes, but we didn't do an adequate job, so we're gonna try again. I will try harder today. Okay, and so these are the four operations I want to perform. I want to draw the vector 2u. How'd you draw 2u? Yeah, this would go up to negative 2, positive 2. So that one was easy, right? So that was 2u. Good. How about negative v? Yeah, I would go in the opposite direction. So as my good friend Nathan said, who came to visit this morning, do some math, good times. Negative v. Excellent. How about u plus v? This is where I want to focus off of yesterday. I didn't clearly explain this. Tyler brought this up, and I appreciate that, Tyler. I'm going to I'm going to erase this to give myself a little bit more space. You guys don't have to draw a new one, but if you want to, you sure can. I have this. I need to build vectors off of their terminal points. So as you do u plus v, you're first going to sketch u. And u is going to be from 0, 0 to negative 1, 1, just like that. So that's u. And then from there, I'm going to build v. So from this terminal point right here, I'm going to start sketching v. So how would I do that? I would go over how many and up how many? Over 1 and up 2. So as I go over 1 and up 2, that's vector v. Now, you guys said, well, Mr. Gintz, vector v, it starts down here. No. It doesn't have to do that. We talked yesterday that vector, by definition, has a certain magnitude or length, and it has a certain direction. Now, this vector v is the same as that one. But when you add vectors together, so this is what I want to build up from yesterday, add or subtract, we have to go initial point to terminal point, and then that initial point connects to that other terminal point, we go there. So you keep on adding on to the ends of the vectors, okay? Because the previous one, the vector v, which we drew right at the beginning, was over 1 and up 2, right? That's the very first one that we drew, right? The very first one that we drew was right there, right? Those two are the same. So that means that u plus v, I just drew v, so u plus v is going to be this one in blue. This one in blue right here is actually u plus v. Nope. This is the drawing you should have, because u we start with. We start with u, and it starts at 0, 0 and goes to negative 1, 1. V goes from here over 1 and up 2 to there. So this vector would connect them together. That's what we should have. So blue represents u plus v. See if you could do v minus 2u on your own. So if you want to draw a new sketch, go ahead. I will slowly work on that problem, and you can check up here to see if you got the right answer. Let's see if you could do v minus 2u on your own. So what I have in red represents v minus 2u. Is that what you got? So the green line is v, and then u looks like this, right? So negative u looks like that. So that's a negative 1u. That is a negative 2u. Any questions off that? Going once, twice, thrice, gone. So your first part of your assignment will be trying problems out of your book that look like that, okay? All right? Are we good? So we're good to go there. Let's turn to our notes. We will finish off what we were working on yesterday, starting with example 7. Now, there was a question from other classes about problem number 23 in your homework, and what we do right now should hopefully connect with that and kind of clear up any questions you may have. But if you have a question, please ask. And we will upload this for our good friends. Are all our good friends at the opera? So Thamantha Stanley and Macy Paul. And do you wish to send them any message? Levi, as you were in Florida, please bring something back for Mr. Gentz. How about a seashell? Or some sand? Or money? Or a math t-shirt. Thank you, Levi. Math t-shirt. Bring me back a math t-shirt. Probably not going to happen. Okay. Let's go here, okay? This is a vector. And I want you guys to realize, so to pick up from where we left off, vectors can be written in a couple different forms. This is a component form. You see a horizontal component and a vertical component. You could also write this, if you care to, like this. It could also be written as negative I plus 2j. Those are the same things. They're interchangeable. So as you see the second problem here, it's going to model identically with what you see with the first, basically. And it asks us to find the magnitude. And the magnitude of a vector is defined as the length, or the absolute value, the distance from the origin. Do you remember how we find that? Square root of a squared plus b squared. Very good. Which is what? Square root of 5. Super smart Nathan. Square root of 5 is what we get. That is the length of the vector, the magnitude of the vector. Square root of 5. The other question is to find the direction of the vector. So when we were referring to direction, we were referring to if you have a vector, say, headed off in this direction, like so, then we are looking for this angle, okay? So as you see, -1, +2, which quadrant is that going to be in? It's going to be in the second quadrant. So we're looking for an angle in the second quadrant. And we can relate theta by this property. We know that the tangent of theta is equal to B divided by A, or 2 divided by -1. And I could do the inverse of it. Now, the negative simply tells me which quadrant I'm working in, right? We know which quadrant I'm in, don't we? The second quadrant. So let's just disregard the negative sign when we inverse. And we will go second tangent inverse of 2. And I get 63.43. So that means that as we sketch the angle, I have a reference angle of 63.43 degrees. So what is actually going to be theta then? You got Whit? 116.57 degrees. Very good. Yeah, I did 180 minus that. Remember that when you do tangent inverse of any trig function, you hope to just come up with a reference angle. You have to use your knowledge about the quadrants in order to find the actual angle. I didn't use a negative. I used the negative to simply determine that I'm in the second quadrant. You know, I drew the shape. -2, or -1, so back 1 and up 2. That means I'm in the second quadrant. See if you do the second problem on your own. And if it helps you to rewrite it in, you know, your component form, then go ahead. You know, so give that a shot. I'm going to pause the video and come check and see how you guys are doing here real quick here. So you should have gotten 2 squares of 3 over 3. We could quick look at how that happens. Again, we know that the magnitude of V is equal to the square root of A squared, or square root of 3 over 3 quantity squared, plus B squared, which is -1 quantity squared. What is square root of 3 squared? 3, and then 9, or I'm sorry, 3 squared is 9, so you get 3 over 9, which is 1/3. So we have the square root of 1/3. That's what we get here. And what is -1 squared? 1, or 3/3, right? So you have 1/3 plus 3/3, which is 4/3. So the square root of 4/3. So I'll take the square root of the top. Square root of 4 is dos. Over the square root of 3. Can you have square root of 3 in the denominator? No. So multiply top and bottom by square root of 3 to rationalize the denominator, and you get 2 square roots of 3 over 3. So that is your magnitude. Jalen, you want to tell us what you got? That's a very good try. Just 300. We'll show you, okay? Which quadrant are you working in? So if your component is square root of 3, 3, and -1, that means you're going to go over a certain amount and down a certain amount, so we're in the fourth quadrant. Right? So we're in the fourth quadrant here, so we'll keep that in mind. And remember that the tangent of theta is equal to B divided by A. So that means -1 divided by square root of 3 over 3. So I don't need the negative. The negative told me which quadrant I'm in. I know which quadrant I'm in, okay? So I'm just going to inverse tangent that value to come up with a reference angle. Tangent inverse of 1 divided by second square root of 3. This is maybe where, whoop, I got to put a parenthesis in there. Is that what you didn't do? And you can see I get 60. So that's a 60-degree reference angle in the fourth quadrant. So that's 60 degrees. So if that's 60 degrees, again, the angle that I'm looking for is this angle. So how do you find that angle? 360 minus 60, which is 300. Nathan, you got all that? I mean, Alex, you got that one on your own. Good. So did you do it just like we did? Did you type it in tangent inverse just like that? Or did you come up with a decimal or? Okay. Yeah. So some people want to reduce this right away. Some people are like, Mr. Gens, I thought that we would have to simplify this right away. Why? I mean, this isn't a final answer. We're just using this to come up with an answer. So I know some people are like, well, you have a radical in the denominator. Who cares? Right? I mean, who cares right now? I mean, it's not a final answer. We'll just use it. So good job. Okay. Example 8. A man pushes a lawnmower with a force of 24 pounds. A handle forms a 40-degree angle with the ground. Find the horizontal and vertical components of force. Now we are going to tie everything we did together over the past day, and we're going to apply it to a word problem. This is a great example. I did it wrong second hour. I made a mistake. I know. And it was really frustrating because when I worked the problem out ahead of time, I actually had done it right. And when I checked the book, I looked at the book incorrectly and thought I had done it wrong. So I taught it differently and then ended up kicking myself in the butt. So fortunately for you guys, we got this figured out. We're all good to go. So watch my drawing here. It is excellent. See if you can keep up with it, okay? We're going to draw a man. So, of course, he will be blue. Lawnmower. Oh, this is a bladeless lawnmower. Yeah. You know, I don't appreciate your talking back, Ryan McLaughlin. Maybe if you don't have anything. Yeah, how about that? Do you have flowers on yours? Look at that. I don't know. I think that this looks phenomenal. What do you want? An engine? Show me your lawnmower. Where's yours? You drew us. Oh my gosh. Okay, I'm done with this conversation. I'm done. It's not being productive. Okay, we're, we're not productive anymore. You're not productive. Okay, all right. So, uh, man pushes a lawnmower with a force of 24 pounds, and so that can be represented as a vector. So he's pushing this handle with a force of 24 pounds. So we're going to call this 24. That is a vector. He's pushing in this direction. Yes. We use math. Very good, Jalen. Jalen just, she's drawing a connection here between math and science. And mathematics is the language with which science explains the world. So we will go like this. It says that the handle forms a 40-degree angle with the ground. 40-degree angle with the ground. Okay? Now, it says find the horizontal and vertical components of the force. Now, I don't care how you look at this. It doesn't really matter to me. I will allow you guys to tell me how you want to operate, and we will go from there. I will show you. Which triangle would you like to use? The triangle to the upper right or to the lower left? Okay, let's use to the lower left, okay? Can you see here that this triangle to the lower left has a horizontal component and a vertical component? And that the horizontal component and the vertical component make up the original vector of 24 pounds of force. So what I want to do is I want to find this vertical component, which we call B, and this horizontal component, which we will call A. Now, this is nothing rocket science. This is something we've done before. But the other day, we were given some formulas. Yesterday, we were given a formula, and it said this. The horizontal component is equal to the absolute value, or the magnitude of the vector, times cosine of theta. And you were also told that the vertical portion of the vector is equal to the absolute value, or the magnitude of the vector, times sine of theta. Well, that shouldn't be that surprising. Look at our drawing. You have a 40-degree angle. Tell me, which trig ratio would you use to figure out A if you were given 24? You would use cosine. You would say cosine of 40 is equal to A divided by 24, and you would solve, and you would use that. Similarly, which trig function would you use to solve for B? You would use sine, opposite over hypotenuse. So this is something we already know how to do, but vectors help us explain it in this way, and this is the formulas that they give us. You could use just simple SOHCAHTOA and figure it out. So at the end of the day, this is what we use. So we can just simply type this in. A is equal to 24 times the cosine of 40 degrees, and B is equal to 24 times the sine of 40 degrees. Take out my calculator. 24 cosine of 40, 18.39. $15.43. Sure. Pounds. Yeah, pounds of force. Now, let's think in terms of a coordinate plane, you guys. If I think in terms of a coordinate plane, I'm pushing horizontally to the right, so that's positive, right? Okay. And then I'm pushing down, so that could be positive or negative. So technically, this vertical component of negative 15.43 should be a negative value. So the component vector that makes this up would be 18.39, comma, negative 15.43. You should make it negative. Yep. If you miss it, I will take a very small amount of points off. Now, here's a point that I want to make. Negative 15, okay? What that means is that you're adding 15 pounds of force vertically, okay? Down. So let's say that the lawnmower weighs 100 pounds. If you were pushing on this lever with a force of 24, what would the lawnmower actually weigh? 100 plus that additional 15, okay? So that's how much vertical force is currently on that lawnmower. Does that make sense? Okay. And now our last one. You have a lawnmower drawn, Nathan? Would you like to show the class? Okay. Can I see this? I would. Can we have an impartial judge decide who's okay? Come on up. Come on up. Who has a better lawnmower, Devin? Who has a better? Look at mine. Look at Devin's. Look at Nathan's. Look at mine. Look at Nathan's. Who has a better lawnmower? You tell me. Who? You fail. You fail. You're done. You're done. You'll find an add drop slip in your mailbox at home. All right. I want to give you a problem that models more closely what you're going to see in your homework. So let's switch this from west to east. I looked at your homework. your homework doesn't appear to really have a problem like that, so we'll keep this, okay? All right. A plane is headed east. I'm going to draw this basically on the bottom. We'll have to move back and forth. But the plane has a speed of 450 miles per hour relative to the air. The wind is blowing north 20 degrees west at a speed of 60 miles per hour. Okay. What does that mean relative to the air? Somebody explain what that means? Anybody know? Okay. Anybody ever been to the airport and you seen one of those like moving sidewalks? Yeah. And you can stand on that moving sidewalk, and as you're standing, what is your current speed relative to the moving sidewalk? 0. You're not moving at all. But your true speed, you would have the speed of whatever the actual moving sidewalk is, right? So that's what we're saying is that as you have that additional wind speed, that's not necessarily accounted for in the odometer of the plane. Okay, so that's something we have to keep in mind. So even though the plane is moving at 450 miles an hour, that's relative to the air. It might be moving at an actually a little bit different speed. So I want to draw this real quick, okay? I'm not going to draw a plane this time. I'm going to simply draw a vector. It's moving straight east. If I'm headed straight east, what is my angle? Let's forget about what we talked about with northeast, southwest the other day, okay? Think about this in terms of the coordinate plane. I'm moving this direction. That would be 0 degrees, okay? All right? And it says that the wind is blowing north 20 degrees east. So from north, I move 20 degrees to the east, and that is going to be, we switch it to east. Switch it to east, okay? I'm sorry. I want to give you guys a problem that models more closely to what we saw. So I got to switch it. Okay, so we're going to make this vector like that. Now this vector formed by the plane has a length of what? A magnitude of what? 450. And then this vector has 60. Okay? There we go. Now, you told me, okay? You told me that this plane right here, what angle is it headed at? 0 degrees. If the wind is blowing at a speed, or if it's blowing 30 degrees east of north, 20 degrees east of north, okay, what would this angle be right here? 70 degrees. Okay? It should sum to 90. North is going to be straight up 90. Okay? And it says it's blowing 20 degrees east of north. Does that make sense? I'm just drawing I'm just drawing a vector to represent that we have wind going like that. Okay. I don't think so. We'll see how the problem plays out and see if that answers your question. Then, if it doesn't, then we'll try it again. Okay. So, okay, here we go. So it says express the velocity of the wind as a vector in component form. So remember that a vector can be written in this form. A, B. And we know that A is equal to the magnitude of the vector times cosine of theta, and B is equal to the magnitude of the vector times sine of theta. Okay, and so that's what we want to do. Oh, sorry, email. So I want to write a component form of this vector. So I'm going to be over a certain amount A and up a certain amount B. Okay, That's what I want to express right now. So I just plug it in. What is the magnitude of the wind vector? So 60 times the cosine of, what is the angle? 70 degrees. And then I will have 60 sine of 70 degrees. Because we're talking about the wind right now, and we're not talking about that. We'll do the jet here in a second. Okay. So 60 cosine of 70 and 60 sine of 70. What do you get for 60 cosine of 70? You get 20.52. and 56.38. Okay, so there's a component form. And so if we actually go down here, you guys, if we were to, move over 20 units and then up 56 units, that would bring us to the tip of this vector right here. So that's what we just found, okay? Now, it says express the velocity of the jet relative to the air as a vector in component form. So now we want to do the jet one, so now we're going to do 450. So we have 450 times the cosine of what? 0. And we have 450 times the sine of 0. Now, does the jet have any vertical component to it at all? It does not. And so that should show up in our answer here. And if you take 450 times the cosine of 0, well, the cosine of 0 is 1. And 1 times 450 is 450. And sine of 0 is 0, and 450 times 0 is 0. So we have 450, 0. So again, if you look at our drawing for the vector of the jet, if you go to 450, 0, that would bring you to the tip of this vector, right? So we found basically those tips of the vectors. It now says find the true velocity of the jet. Well, the velocity of the jet is going to be defined as the sum of the vectors. So I'm going to call this the W vector for wind, and I'm going to call this the J vector for the jet. So the true velocity of the jet is equal to the wind vector plus the jet vector. Did you learn how to add vectors together yesterday? Yeah. So we simply take 20.52 and add it to 450. So 20.52 plus 450, which is 470.52. And then to find the vertical component, I would add 56.38 to 0. I get 56.38. So that represents the velocity. And the reason we like that is velocity has magnitude and it has direction. And vectors like this, they have magnitude and direction. We could plot that and see where that is. Well, notice what happens, you guys. If I were to draw that, if I were to go over 470.52, I think that, Tyler, I think this brings up a point that we were talking about from physics yesterday, that this would actually bring you, slightly past that 450, and then up to that 56 spot, somewhere right here, that's the point that's plotted. Well, look at that, you guys. That's just the sum of the two vectors, isn't it? The true speed is represented by this. You know that this is 60 right here. And Tyler, you said that you guys were able to use the law of cosines, right? Well, we don't even need to use the law of cosines. What? No, 20 degrees past. So 20 degrees past 90. Yeah, remember, it's no, this is not a 60-degree angle. It's a 60 magnitude vector. Yep, that's all right. I won't belittle you as you just did to me. So So in order to finish off this problem, it says find the true speed. Well, in order to find the true speed, I'm going to look at this component form vector. Okay? Speed is identified as the absolute value of velocity. The absolute value of velocity. And so I know how to find the absolute value of v here, or the magnitude of this vector. How do I find that? Square root of 470.52 quantity squared plus 56.38 quantity squared. Type it in. $473.89 miles per hour. So what that means is that as the plane's flying through the air at 450, it's actually traveling at 473 because it's got some help from that wind. It's traveling faster than the odometer reads. Does that make sense? So that's what we got. So that takes you through everything that we need to know. We will have a work day sometime next week. I don't know for sure when it'll be yet, but these are the problems I'm going to ask you to work on over the weekend. Page 600, numbers 1 through 6, 33 through 40, 43, and 44. They should follow identical to really what we've done in class today. And good job keeping up with your homework, but that's it for 7-7. We just need to do 7-8 next week, and then we'll be ready to test. So our next test will be on 7-6, 7-7, 7-8. So make sure that you're caught up with that and ready to go.